Oh, wait. There we go. All right, now it's working. All right, so welcome everyone to Kopernik tonight. Looks like a full house. That's awesome to see. Now, I'm going to do a little brief intro here, talking about some of our upcoming programs. So let me go to our website. You can go to Kopernik.org, always to learn more about our. Hang on, this page. Sorry, I had two things up. Go to Kopernik.org to learn more about our upcoming events. And we usually have some kind of banner that updates you on some of the recent programs we have going. This one's discussing the lunar eclipse in this case, which we'll get to in a moment. Tonight's program is by Robert Seegers, one of our Kopernik educators. So we'll get started on that in just a moment. On Sunday nights, it's not a program we're holding on site, but it's one that you can tune in over our YouTube channel that will stream live. In fact, we're doing that right now, too. That's what the camera over there is for. Wave to the audience on YouTube. Some people are watching virtually from home this program, and we'll do the same thing for this exclusively virtual program on Sunday night, covering the lunar eclipse. So I'll bounce over to the YouTube page so you can have a look at that. You can subscribe here for those virtual events. This is the lunar eclipse live stream. That image there was taken, it's a partial eclipse that was taken in November, during the November, I think it was the 19th lunar eclipse last year. So this is going to be a total eclipse on Sunday night where the moon goes completely into shadow, into the Earth's shadow, and it goes completely red, unlike what you're seeing here. We still have like that sliver of moonlight. So that stream starts at 8:30, hopefully with some views of the full moon, and we'll keep going as long as the skies behave. And speaking of skies, best place to go to see the weather, the forecast for our site is down here at the very bottom of the page. There's our clear sky chart. If you click on this, click on that, there we go. This will give you a report of the cloud cover, the transparency, and the seeing. Those are the three big things in weather that relates to astronomy and what you can see in the sky. So dark blue is ideally what you want to see across the board here for a really good observing session. But at the very least, you want to see dark blue in the cloud cover at the very top row. So tonight, I think we'll have some good partly cloudy skies to work with, and the moon should break through here or there. So we'll definitely get our telescopes fixed on that if it shows up. And Sunday night for the eclipse, oh, I hope it pans out. Right now it's light blue, which isn't ideal, and hopefully that transitions to dark blue between the hours of 8 and 2 a.m. on Sunday night. So we will see what happens there. Again, that will be a completely virtual event. Last couple of things I'll mention. We do have some class programs coming up in the form of our summer camps. There are still some spots open for those. We have registration forms out in the lobby. Probably the best way to register and check to make sure that the camp is available is to just register online, though. In the form, it shows you how to do that and what website to go to. It's actually right up here on our Kopernik.org under classes and summer camps 2022. For the remainder of the spring, we do have our programs listed here under our public program section. So here's our Solar System Express tour. There's the Sunday night special event that's only virtual. This is next week on May 20th is called A Year in the Life of a Beekeeper. And the final program for May is the Triple Cities Makerspace, discussing those resources that are available to you in the southern tier to start making anything. So look out for those programs in the next couple of weeks, and we hope for clear skies. As always, we will open up our telescopes afterwards, so long as the skies are clear. With that said, I'll get rid of this completely here. And I will pass it off to Robert. There's the clicker if you want to use it. Just hit the right arrow to move forward through your slides.
Yeah, backwards.
Yep, exactly. Good. So thank you, Robert. Take it away.
Well, welcome everybody to our observatory here. And tonight is just meant to be kind of a survey presentation, just to kind of whet your appetites to all that's going on right now in our solar system. We're living in an amazing time where we have spacecrafts around almost all the planets, or certainly have at one time or another. And now we're even looking at extra solar system planets, looking at exoplanets as we call them, looking at other stars and so forth. And we have, of course, the great tools in orbiting Earth, like the Hubble telescope, and then a little beyond that we have the James Webb telescope, which was just recently inserted in its orbit. So just a great time. And tonight we're just going to hit a few of these places, but again, just to kind of weigh your appetite, kind of get you excited about everything that we see out there. So we could actually pick we could have picked any planet and spent a whole night, night after night, talking about them. So we're going to kind of, like I say, it is an express tour. We want to get you guys out there to look at the telescopes. So I should say they're spacecrafts that look at the sun. We recently had a Mercury spacecraft called the Messenger not that long ago. Gave us absolutely incredible detail of Mercury, and there's currently a mission at Venus that's investigating Venus's atmosphere, even trying to probe below to see what it's like. And of course, Earth. We have all kinds of things here, and so forth. So we're going to start. We'll move ahead to Mars. This is a Hubble telescope image of Mars. And this is the planet. We're so intrigued with Mars, and it's basically the closest to Earth. Even though Venus is also also our neighbor, and also the same size as Earth. It's Mars that really is most like the Earth in characteristics. So, and it's kind of interesting. Back in the around 1880 or so, there was an Italian astronomer by the name of Schiaparelli who made some maps, and he called them the canali of Mars. And the English astronomers thought he meant canal. So all of a sudden, you can see the lower image. There's an elaborate canal system built on Mars, which of course must have been built by Martians, right? So up and through about the 1950s, people believed there was a really good chance of alien life on Mars, kind of like us, I guess. And that all changed in the 1960s. We had our first orbiting spacecrafts around Mars, and we realized Mars, in many ways, was more like the moon as far as the surface seems kind of dead. But again, those were kind of basic, very rudimentary pictures, photos that now we see a lot more, as you're about to see. And here's one of the earlier rovers. You can just see Mars has got a sky. There's an atmosphere on Mars. It's thin. It's primarily carbon dioxide, but the sun does go through the atmosphere, and you have day and night. And actually, Mars, much like Earth, has a 24-hour day, pretty much. It's very interesting how it's almost exactly the same. There is water ice on Mars. We're finding it that's in the polar region, of course, but there's also other spots that we have found. And we know Mars had a much watery past, but we're still looking for that, and maybe the possibility of life. And you can see some of these close-ups now. This is actually from Perseverance, which is the new rover on Mars. And you can just see the detail of these pictures. It's just amazing. This rock has a name. It's called Harold's Wick. But just amazing. It looks like it could be out in like Utah or Wyoming or something. Just absolutely phenomenal. Again. And here there's an area now, it's called the Jezera Crater, and here is a ridge that Perseverance is looking at now. Oh, this is pretty cool. This is actually, this is a solar eclipse. Now, Mars has got two moons called Deimos and Phobos. One means panic, and the other means fear. They're both just like giant potatoes that orbit Mars, essentially. They're about 17 and 13 miles in diameter. And Phobos, the larger of the two, is actually, I want to say, 80,000 miles from the surface. So it's, even though it's really small, it's actually really close. So the sun, of course, would be smaller in the sky compared to Earth. So you have these eclipses. So this is a lunar eclipse here with that. So I should, a reminder too, we actually do have a solar eclipse. I'm sorry, this is a solar eclipse. We do have a solar eclipse coming up on 2024. I believe it's on April 8th. And we're going to be at a pretty close to 90% here. But if you go just a little bit north or a little bit west, you can get to like 100% totality. So book your hotel reservation soon. Okay. One thing too, before and I'm sorry, I hope I'm making you busy here, but one interesting thing about Phobos, there is talk about visiting that moon, and what a lot of scientists theorize is that when Mars's atmosphere escaped, like something happened, the atmosphere went back into space, that Phobos might have gotten blasted with a lot of the early Martian particles. So it warrants, I guess, further investigation.
Robert?
Yes.
Was that a video taken from the surface of Mars by one of the rovers?
It is. Thank you. This was by Perseverance, actually.
Oh,
yeah.
okay.
Yeah, thanks. Yeah. So we're going to leave Mars, and we're going to go to a place that doesn't get that much attention, the asteroid belt. And the asteroid belt is, if you look at where it's located, it looks like there should be a planet there. If you look at the distances between the planets, and there's something called Bode's law, which actually kind of predicts where all these planets lie, distance from each other. But it's possible, the leading theory is that maybe a planet did form and either couldn't form, couldn't stay together because of Jupiter's gravity, or maybe some interloping, object came and smashed into it. But anyway, there was a mission there called Dawn. We recently learned a lot about the asteroids in the asteroid belt. But the biggest one, which Dawn visited, is Ceres. The Ceres is, I want to say, about 550 miles across in diameter. It's spherical too, so it's large enough to be spherical. And I want to say that it makes up, Ceres itself makes up close to 90, 85 maybe % of the asteroid belt. So it's for the asteroid belt, it's the big boy. So so a very interesting world. They found that there's water, ice, so it's like brine, so they believe there's an ocean underneath this surface here. And you can see, actually I'm going to drop the light here. Okay. Is that better? So you can see the detail, it's amazing. And you can see these bright white spots, and they were a bit of a mystery. Oh, thanks. They were definitely a bit of a mystery. So, and here is this Educator crater. You see these white spots. So what is that mysterious white? It turns out it's sodium carbonate, which is, I guess, like they use for detergent and stuff. So we have a space station on Ceres, I guess. You have to bring laundry detergent with you. It's already supplied. Here's another crater, Urbana crater. And we're moving on now to Jupiter. And Jupiter, of course, the largest of all our planets, just under 89,000 miles in diameter. Now that's about 11 times the diameter of Earth. And the red spot alone there, the giant, which is the storm, which has been apparent in Jupiter's atmosphere since the very first telescopes, looked at it in the 1600s. That red spot has been there. It's just an ongoing storm. You could fit 3 Earths inside that red spot. Of course, the hydrogen and helium atmosphere, a lot of the bands in the atmosphere. So we've had a number of spacecraft visit Jupiter. I guess the very first ones were the Pioneer spacecrafts. They flew by. Then they had the Voyager spacecraft. And then there was a Galileo spacecraft. And then after that, there was the New Horizons on its way to Pluto stopped there. But now we have the Juno mission that's out there now. And you can see it's actually got really, it's super heavy. There's a lot of lead in it because Jupiter's radiation is really powerful. So they don't want the spacecraft to cook. You can see, so it's really well protected. You guys can take a look at that. These are like, I think, the largest solar panels, too, put on a spacecraft to date. And as we said, the radiation is very, very dangerous. On top of that, Jupiter has a pretty amazing magnetic field. In fact, they say that on AM radio, which isn't too popular anymore, but at night sometimes you would hear these strange sounds on your AM radio, like if you're driving your car, and that was actually caused by Jupiter's magnetic field. So this shows you how far-reaching it is. And here, like I mentioned, the different spacecrafts that have been there, and the timeline here. And one thing that Juno will be doing is probing, obviously, into Jupiter's atmosphere to see what's underneath there. Like, is there a metallic hydrogen, for example, and so forth. And what basically just tracking those storms that we see constantly in Jupiter's atmosphere. And here is a Juno image, you can just see how massive this planet is. Recent image. Swirling cloud. And this is just a the diagram shows you how the different bands, how they're going in opposite directions, which we do have that on Earth to some degree as well. But not quite as windy on Earth as it is in Jupiter. So we're going to shift our attention a little bit to Jupiter's moons. Jupiter has probably upwards, technically I think like 70 or 80 moons probably by now. But there's 4 giant moons that we've known about. When Galileo was observing Jupiter in 1610 with his telescope, he actually found them. So that's why they're called the Galilean satellites. And here are some original drawings here, these copies of them, and you can see the circle you see on the left, that is Jupiter itself, and you can see on different nights there could be, as few as, well in this case 2, but there are times you can see 1, but up to 4. So he figured out that there were 4 of these moons. Their names are from moving out from Jupiter are Io, Europa, Ganymede, and Callisto. They're very, very important. Here is Io, and this is the closest one to Jupiter, and it's just being ripped apart. Jupiter's gravity is so powerful. It's just ripping the inside of this moon out. And it's a lot of sulfur you're seeing here and so forth. And it's the most volcanically active object in our solar system. And it's massive too. It's about the size, maybe even a tiny bit bigger than our moon, but basically the same size as our moon. Here's a close-up more of those storms. Oh, I'm sorry, of the eruptions here. Now, one thing the Juno spacecraft found recently, like just a matter of a week or 2 ago, they found these sand dunes. It's not the best resolution, but that's what we got here. So they're thinking, how could there be sand dunes? There's not really much of an atmosphere that would, the atmospheric pressure would be so low anyway that we wouldn't create something like this. But what's happening is they're saying that the lava flows are mixing with the sulfur down below, and it actually creates like this big venting process, and that is powerful enough to basically make these dunes. So you'll probably be hearing more about this. All right. Moving on to Europa. And Europa is one of the hot spots right now for possible life elsewhere in our solar system. What you're looking at is a very icy crust here, and just below that crust is an ocean, a saltwater ocean, just like we have here on Earth. And there could be like some geothermal activity underneath the ocean's floor there. So what we're trying to develop, a spacecraft that could maybe go there and, without, possibly contaminating the world, but maybe try to find out if that's the case. How could they get below the ice? There's a mission called the Europa Clipper, which is going to be there, I guess, hopefully pretty soon. So let's see what we got here. I wanted to show you something here, but it's a little clip. Let's see if I can do this. Let's see where we go.
NASA's Hubble Space Telescope has directly imaged what may be plumes of water vapor on Jupiter's icy moon, Europa. Europa has long been thought to harbor a global ocean of water beneath its surface of ice, making it a prime target of study for anyone interested in searching for alien life. Eventually, our search for life will take us into that ocean, but until then, the existence of a water vapor plume will provide an early glimpse into the ocean's conditions. In 2012, a team of astronomers used the Hubble Space Telescope to observe a faint aurora from the interaction of Europa and Jupiter's magnetic field. They detected emissions in wavelengths characteristic of the breakup of water molecules. And after considering a wide variety of causes, the team concluded that the most plausible explanation for these spectroscopic measurements was the existence of plumes of water vapor erupting from the surface of Europa. Now, a different team of astronomers has used a different method with similar results. They used Hubble to image Europa in ultraviolet light as the moon transited across the disk of Jupiter, and were actually able to take direct images of what appear to be the silhouettes of plumes rising about 125 miles above the surface of Europa. If these observations are indeed of water vapor plumes, then they approximately match the 2012 observation estimates for the plume's mass, height, and location. Also, these plumes are transient, meaning they come and they go. Out of 10 observations of Europa transiting across Jupiter, the team saw possible plumes on just 3 of the transits. Both the recent observations and the 2012 observations provided evidence, not proof, of water vapor plumes on Europa. Science is a process, it's not always cut and dried. But future observations by Hubble and infrared observations by the James Webb Space Telescope could continue to build a case for the existence of these plumes on Europa. And then NASA's future Europa flyby mission would continue the search for the plumes and visit them to look for evidence of a habitable underwater world.
Ice shelves you can see. Almost looks like, you know, the Susquehanna on a winter day here. The next one out is Ganymede, and that is actually the largest moon in the solar system. It's larger than the planet Mercury. And we'll be learning a lot more about Ganymede as the missions continue. The Juno spacecraft itself is not going to really spend too much time really focusing on these moons. They're not going to do really any close flybys or anything, but still, we'll get to see plenty of images taken from its cameras. Also believed to be maybe a saltwater ocean under Ganymede as well. And then the fourth one is Callisto, very ancient surface. You can see all the bombardment of you know, all the different debris that's hit it, all these craters. You didn't see that on the surface of certainly the other 3 moons. So, but this one you do. So it's a much, much older surface, but also believed maybe to have an ocean underneath. One of our favorite spots here, after one last thing, that's actually Ganymede. It looks like it's holding Jupiter up. Just shows you as big as Ganymede is, how, you know, petite it is next to Jupiter. So moving out to Saturn. So by the way, Jupiter is about 500 million miles from the sun, and Saturn is just under 1 billion miles from the sun on average, like 900 million. And you know, we could spend a lot of time with Saturn. We recently, the Cassini mission concluded. We learned a lot about Saturn, and of course Saturn's moons as well, which we'll get to in a sec. But just so kind of neat to show you the rings, this is a close-up. And you can really see the rings for what they are. I mean, from Earth, we see these beautiful, like, golden planks, right? But here, it's really a blizzard of rocks, dirt, dust, and ice, basically zipping around Saturn at like around 40,000 miles per hour. So as you get closer, you can see those individual particles. And there's different groups of the rings as well. One thing we noticed, too, that sometimes the rings seem to be braiding a little bit. And that's what we found with what they call shepherd moons, these little small moons, maybe any, you know, upward to like maybe 90 or 100 miles across. Most of them are smaller than that. And you can see there's a little bit of gravity from those moons that are in with the rings actually causes them to twist a bit. So one of them is called Prometheus. So we'll just go right to the main ones here. And one of them is Enceladus. Enceladus is actually the most reflective object in the solar system other than the sun, because it's covered with snow and ice. And you can see a very, very smooth surface, right, compared to our moon, right? So what's going on is that, again, the forces from Saturn and the gravity from the moons nearby just pulling on the inside of this moon as well. and you're getting basically, it's minus 340 or whatever degrees out there, it's pretty cold. But while that friction warms things up as he's pulling the ice up, and that ice melts and kind of shoots up into space in the form of a geyser, and of course comes back down as snow and ice. And of course some of the material even goes into Saturn's E-ring. Let's see, some geysers right there. So we think Enceladus along with Europa are two of the best spots for maybe life. They're both water worlds, so you might find life in there. On our own planet in Antarctica, below the ice, we find teeming, life teeming down there. So again, the key is how do you go there without, without contaminating things. Plus, by the time you get to Enceladus, you're pretty far away, so the mission would be even longer than Europa. I don't think you can rule out that asteroid Ceres either, so I'll leave that. And then the other big story as far as the moons go is Titan. Titan is very intriguing to us from Earth because it's got the most Earth-like atmosphere out there in our solar system. It's nitrogen. And most of our atmosphere, of course, is nitrogen as well. So basically it's like a super thick atmosphere, gigantic moon. Again, it's just behind Ganymede as far as size. And there are like lakes and rivers and so forth, but it's actually of methane. So it's a very interesting world out there. But we're actually sending a mission out there. It's going to be like a little, I want to say like a helicopter. It's called the Dragonfly, and it's actually going to be going down, hovering above Titan's surface. So you'll soon know a lot more about Titan. Okay, let's see here. Here are some of those features. There's also a lot of sand dunes on Titan as well. So basically what happened was there was a lander that shot off of the Cassini spacecraft called Huygens, and it landed and took pictures for about 45 minutes on the surface of Titan. Again, very kind of Earth, a little bit like Earth, a little bit like Mars. And now we're going to skip over to Neptune, and we don't really have much to show about Neptune, but this picture here was from the Voyager spacecraft back in the 1980s. But there's something very important as far as we're going to the outer solar system, and Neptune plays a really big role. Neptune is sort of like a governor, and you'll get to see that in a moment. So, what else is out there? Oh, you got the Kuiper Belt, just a gigantic swarm of icy bodies that lies beyond the orbit of Neptune. And there's a lot of stuff in that Kuiper Belt, as we're going to see. And I'm not sure what that is. Might be the New Horizons. So anyway, the story goes back to even before 1930. Remember those drawings of Mars I showed you, right? Well, Percival Lowell, who was one of the people who thought there was life on Mars and thought those were real canals, he set on a quest to find Planet X, which was a planet unknown. And in 1930, an astronomer named Clyde Tombaugh actually found, which we're looking at as a series of photographs, it's just looping, but you can see that one dot there in the middle crossing in front of that star. Well, that tells us that's in our own solar system. Those stars are trillions of miles away. They're not going to move in our lifetime, okay, from our perspective. But that's how we can tell something is out there. So that led to this, again, the discovery of Pluto in 1930. And at first, everybody thought Pluto was bigger than Earth, right? So, but then as the decades went, it shrunk down quite a bit in size, as you can see. I think it's about like 1,500 miles across in diameter. I tried to get rid of that one. Okay, but anyway, one thing that's cool about Pluto is its orbit. And it's kind of hard to describe it. And we're looking at it from above or below. And you can see that it crosses Neptune's orbit, but it actually is nowhere near it. It's at I think a 17-degree angle, its orbital plane, so it never actually would ever come into contact with Neptune. Here's another view up from the side. You can see how the other ones are relatively, on the same plane. Mercury's a bit, you don't see it because it's so close to the sun, but Mercury is actually at a 7-degree tip. But the rest of them are less, and of course, you can see Pluto at 17. And until the New Horizons spacecraft arrived there, I guess it's already been about 6 years or so, these were the best images we had of Pluto, and they really are good. They're actually, you can see it enlarged, so there's no detail, but we did see interesting color on Pluto. So that we were looking forward to that. And by the time before New Horizons even got there, we figured out that Pluto actually has 5 moons. Most people don't know that. 5 moons, and they're basically in harmony around Pluto. So there's the New Horizons mission. It's there, and here is the classic photo you see of Pluto, and that heart shape is for real. I got a funny story. Actually, I was here. There was an event called Plutopalooza. Was anybody here for that? Anybody? Well, anyway, it was. So I had a PowerPoint all ready to go, but waiting for the first pictures to come, right? And a number of observatories all over the world was doing this. Anyway, so we finally get the first picture. It's not color. It's a gray one. It's got this heart on it. And my colleague's like, "That's a hoax. Don't put that in, John." But it turned out there was a photo, a real photo of Pluto. And it's got that heart shape to it. And you can see look at the interesting texture, and look how very smooth it is. It's a geologically active world, and tectonically active world. And there's a lot of chemicals below the surface, and of course, even though you're minus close to whatever 400 degrees out there, the freezing points, of course, drop even less when there's other stuff mixed in with these ices and so forth. And pretty cool. That's part of the heart there. Sputnik Plutonian, I think it's called. And you see a close-up of that. So we never have guessed this would have been Pluto. And those ridges are about 7,000 miles high. And then Pluto has an atmosphere. Well, it had an atmosphere. It's got what they call a tenuous atmosphere. As it gets farther away from the sun, that atmosphere collapses onto the surface. But you can see here, when New Horizons got there, you can see the atmosphere was there. In fact, there's actually a blue sky as you were heading out on the backside from Pluto. But now Pluto is actually at a point now where its atmosphere is rapidly falling onto the surface. So it won't be for, gosh, I think it's got a 248-year orbit or whatever it is. So it won't be until it starts getting closer to the sun again where it'll pop back in. So of course with Pluto, the big controversy is Pluto a planet? Well, it is. I mean, it is a planet, but now it's just a matter of what they're classifying. Like they have the dwarf planets, that's the term we're using. They're all what they call, I guess, minor planets. That was a term used back when they discovered the asteroids in the asteroid belt. In the early 19th century, they started using that term. And they're it's being used again by a lot of scientists. So, Pluto certainly is a planet, but it's not one of the 8 what we call classical planets that just go around the sun. And there's reasons for it, but I'll just get to the one big one, and that is that Neptune has a lot to do with Pluto's orbit. For every 3 times Neptune goes around the sun, Pluto goes around exactly twice. And as we've discovered more objects out here, we find other objects like Pluto. There's another one of these guys called Orcus. And Orcus is just a little bit smaller than Pluto. It's tipped a little bit differently, but the same thing. For every 2 times Orcus goes around the sun, Neptune goes around 3 times. And we call those particular dwarf planets, or trans-Neptunian objects, as they're officially called, we call them Plutonoids, because they basically follow the same type of orbital pattern relationship between Pluto and Neptune as Pluto does. We'll go back to Pluto for a moment. It's got a large moon. It's like a companion called Charon, and it's actually about 700 and some odd miles across, which is about half the size of Pluto. So pretty cool. And actually, it's funny. You would think this Charon just orbits around Pluto, but actually they orbit around a point just outside of Pluto's body. So it's almost like a double planet type of thing. Here's the trajectory of New Horizons. It was a flyby. It didn't orbit, so it just went by real fast, as you can see. But it got some amazing pictures, and then it went on its way. It's already visited one new world after, but maybe we're going to see some more. So here are the two, basically the two of the smallest moons of Pluto shown next to each other. These aren't great photographs, they're kind of enlarged, but you can see they're just little chunks. And there are the other two, which were even farther away. So like I said, back in the 1990s, they started finding other objects out there, kind of in Pluto's vicinity. And they found a fairly large one in 2002. They called it Quorer, and that too has orbits the sun twice for every 3 times that Neptune does. Again, same thing. You can see that little dot in the middle there. That is actually in our solar system, and those are all stars behind that. And I told you about Orcus. You can see similar. Orcus has a moon too. It's very, very small. And here is Haumea, and Haumea is kind of unique. It's got it looks like it's got a 7-to-3 relationship with Neptune. So there are different. A lot of these things out there have different ratios to how many times it orbits the sun compared to Neptune. So that's why I say Neptune is so important, because it just seems to control a lot of these worlds out here beyond it. Whereas the aclassical planets, they just go around the sun, not around each other. So here's a closer. This is an artist's view of it. And it's shaped like an egg because it spins so fast. So the equator is the wider section, and then the poles are the shorter, would be the shorter diameter. I think it's like less than 10 hours. And it's actually, believe it or not, it's almost the size of Pluto. So it's actually a pretty big trans-Neptunian world there. And these are just artist images, but there's another one called Maki, which is about the same size as, just a little bit smaller than Pluto. And then here's Eris, which caused a lot of trouble, because Eris is actually, I guess, technically larger than Pluto. And we found that one back in, I want to say 2005. And then there's other ones, but another one that's really, really important is Sedna. Sedna has a super long orbit. I think it takes like 11,000, almost just under 12,000 years to orbit the sun. So it's way, way out there. But it's actually now it's one of its closest points to the sun, which is why we were able to detect it. Okay, so they've actually found other ones now that are a little bit farther away, but they're smaller. Sedna is fairly large. It's about, I guess, 1,000 miles across, at least. And you can see the orbit of Sedna. The purple one is Pluto. Now, Pluto's pretty far out, right? Look how far out this place is, right? Well, they found other objects, like I said, like Sedna, with these crazy long elliptical orbits. And now, there's a thought of maybe there is a Planet X out there, Planet 9, you've heard about in the news. Why are all these, kind of pointing the same way? So we have a lot of telescopes, basically looking for that. Is it a companion to the sun? Is it something that maybe once went by the solar system and is not around anymore? It's a mystery. So it's something that we'll definitely be talking about more in the future. And when we get this far, we start measuring things rather in miles. We use a term astronomical unit, which is basically the distance between the Earth and the Sun. So, for example, Saturn is almost 10 astronomical units away. So that's it gets a lot easier. And of course, once you go past the solar system, then you start using the term light year, because basically a light year is like what, 6 trillion miles? So, and you can see you can't fit all these things on the screen, so that when you use these exponents, it's a lot easier to get the information across. One thing I'll end the slides with is kind of a fun thing to see, and it's the size comparisons. It's kind of a fun thing. You can see the Earth, and you can see how it's kind of the biggest part of the inner solar system, right? It's not so big anymore. So we're into, of course, out of our solar system, we get other stars. And Arcturus might be a star. You can see that I think last week we had Arcturus in the scopes, I think, so you can see it. Still just a dot, but you can see more light.
That one. Which one's that?
You see, the sun is no longer visible. So, not even detectable, right? I guess is. All right. Well, guys, we'll turn some of the lights on here. I want to say too, there's some coloring sheets for the kids if they want to color in some of the planets. Also invite people if you want to read a little bit more information on some of the dwarf planets or etc. They're back there, as well as the dimensions and so forth. Characteristics of the 8 classical planets. These sheets are right there on the other table, so help yourselves. So, thank you.
Do we want to take any questions, Robert?
Oh, sure. I'll do the best I can. And like I said, this is meant to be like just really whet your appetite, and we'll definitely be looking at some more precise topics with these individual planets.
To get us the size comparisons, showing black holes.
Like any black holes, you mean?
Yeah.
Well, there are a lot of black holes out there, but I don't know. There's some in our own, like one I know towards the center of the Milky Way galaxy, but it's really far from us. So.
Yeah. Speaking of Sagittarius A, there, did anyone see the picture of our black hole?
Yeah.
The center of our galaxy. Definitely check that out if you haven't already. That just got released a day or two ago.
what would the size of that be compared to like the larger star?
Oh, look. See, black holes are weird because they're kind of singularities. So where you measure that point, it sort of depends on its influence around the objects surrounding it. So I'm not sure what that measurement would be for Sagittarius A.
I was just
at the
reading
center,
what
but the actual
event horizon
gravity source is a singularity, a single point.
What the hell?
Question over there?
They said it was.
There was a slide where, I think it was, about Jupiter, or maybe Jupiter's moons, where, you were talking about a mission to figure out what is made, like what the core is made up of.
Okay.
How would they possibly get those samples or those measurements from deep inside a planet?
That's a good question. I know there is another mission coming up called Endurance, right? And I know they're practicing in Antarctica. I guess the idea is how do you go down there without, causing, any sort of contamination. So, Jeremy, do you know anything about that yet, or?
Sorry.
The Endurance mission at all? I know they're looking to, see how they can get below the ice of, worlds without,
Correct, yeah, that's a big thing, yeah. They want to actually, both Enceladus and Europa at some point install, they definitely want to break through that surface. If you can access that ocean, who knows what you'll find down there.
Right. It's kind of interesting because have you read War of the Worlds? Or do you know the
I've
story?
seen the movie.
Yeah, well, it's interesting back in 1900 when it was written that what you just mentioned, it plays a big role in what happens to the Martians, right? So it's definitely ahead of its time, but yeah, so that's a really good question. Well, see, because we really want to see these worlds. We feel these are the best places that we could find other life. So, but we don't want to ruin it. Yeah. Good question. Any other questions at all, or?
About 3 slides ago, or 4 slides back, there was something about a hydrogen belt or something.
Oh, Kuiper Belt?
Okay, yeah.
Yeah, the Kuiper Belt is like a swarm of these icy objects that lie beyond Neptune, and that's where the planets like Pluto and all these other worlds you saw, that's where they lie. Now, some of them lie beyond it, like Sedna, and even Eris lies beyond, a bit beyond the Kuiper Belt. But, yeah, it's just, and beyond that, at the very edge of our solar system, is theorized as something called the Oort cloud. And that's where they believe all these comets come from. And their orbits are even longer than that Sedna that you saw. So yeah, it's a Kuiper Belt. And the New Horizons mission is still going. It visited another world, which they changed the name so many times. I think the last was called Arrokoth. It was like sort of a snowman-shaped world. And I think they found another world to visit too out there. So you're going to, you will hear about the Kuiper Belt more and more. So. Good question over here.
What is that?
That I think is probably like an asteroid. I think it's just an artist. That's a fun thing. Some of these worlds are so far away. If we just showed you little dots, you probably wouldn't come here anymore. So we have to use artists like interpretations of things. But I should tell you that most of the artist interpretations that are used are based on the little knowledge we have, the little bit of science that we know about these worlds. So it's not probably too far off in theory. So. But it's still very, very speculative and imaginative. So, yeah.
Do you have an idea of Saturn's orbit at its extreme farthest from the sun, how far out that is?
Well, look, I think when it's its closest, it's at 70-something. Let's see.
That's AUs?
Yes, exactly. Okay, Saturn ranges from 75 to 900.
Oh, okay.
So that's a lot. That's quite a range.
Yeah.
And we're lucky now that Saturn is actually at its closest, just about at its closest point to the sun. There's actually talk of sending, believe it or not, getting a mission there.
What's
so
that?
There's talking about sending a spacecraft there.
Really?
So we'll see what happens, but this would be the time to do it. Yep, while we're still here. So any other questions else over here?
Does the Earth move?
Does the Earth move? It does. It does. It moves right. It goes around the sun, so it makes a circle around the sun, and it also spins around itself. Like there's a big pole in the middle, almost like, and it turns around. That's why we have daytime when we face the sun, and we see the stars at night when we're faced away from the sun. Good question. Thank you. Any other questions? Like I said, keep your eyes out. We're going to have a lot of programs coming up, certainly in the fall, but we'll have some in the summer as well. but we'll get more specific topics there, so we'll do that.
How long has space been around?
I know they're using telescopes to try to figure that out, but the important thing is, let's just observe the beautiful things here. There's so much space. And we're discovering more space all the time, right? So.
This little girl over here answered her.
All right, thanks. Any other questions at all? Or?
What about Uranus?
You know what? They're hoping to get another mission to Uranus and Neptune because they're really important. They also have really cool moons that orbit those two planets. So that's also something they're hoping to launch here in the next few years. So that'd be pretty exciting because there are worlds there that are not that cratered, which means they too could have processes going on, like things moving around under the surface that fills it, like ice or water or whatever. So keep your fingers crossed, and hopefully we'll see that here in a number of years. And by the way, I should say it's taking less and less time to get to these places as our technology improves, So, question like that?
I just wanted to ask about Pluto's orbit when it was kind of skewed as what caused that? Is it the distance from the sun side?
What's that?
Probably when it established its orbit, it's the way it was kind of put in. And like I say, it's definitely governed by Neptune as well. So most of those objects you see out there are like on some sort of tilt, and Pluto's a 17. But yeah, and there's also theories too that maybe like Pluto might have been an inner moon, like one of the moons of Saturn or Jupiter, and it somehow got shot out, and then it got captured out there. So like Neptune. Yeah, Rocket Fest is coming up too. Got to remember that. What's that?
Oh yes, that's one I didn't mention. So Rocket Fest is coming up on, come to the front here. Rocket Fest is coming up on June 11th. And there are registration forms out in the lobby, but again, probably your best bet is to just register online. That's is where you'll order a rocket, either beginner, intermediate, or advanced. You'll choose that. We'll get it to you. Either you can come up to Kopernik, or we'll have an event at Barnes & Noble where you can come there, just ease of access. And then you'll build it at home. And that gives you a lot of time to tweak the rocket itself. We changed this. Originally we had you build it up here, but we found that we had so many cool designs last year when we had you build it at home. So we want to keep that up. You'll come up, you'll get a launch window on June 11th, and you'll come up during that time, and we'll launch it on our site either out in the parking lot or down at the field. So that's June 11th coming up. Were there any other questions for Robert?
My daughter just reminded me that just kind of a funny story. On January 1st, in 2019, we were baking cookies. We were trying to make macaroons. They didn't come out anything like they were supposed to. But coincidentally, that very night were the first pictures of that other world that the New Horizons visited, Europa. And me is showing you the pictures, but they look exactly. They look like is that our cookie? So it was kind of a funny story, and she loves to talk about that.
That's so cool.
Anyway.
All right. Well, at this point, let's get some lights on here. And we are going to get our scopes going outside right now. The big portable scope just outside the telescope doors there is fixed on the moon, and we'll do the same thing for the 6-inch, so you can look through one of our dome telescopes as well. I think the skies are behaving well enough to at least see the moon tonight. All right, and those that are on YouTube, thank you so much for joining us this evening. We'll see you maybe on Sunday night.